Hello Year 12, we're going to start our next section, which is chapter 1 from the P2 book, and we're working on algebraic methods. So the first thing we're going to do is to review some work that we should know already, and let's get that really good. And then we're going to move on to some work on partial fractions, and we get a bit of algebraic division in there, so that's always a treat. So could you start please with the warm-up questions in your booklet? There's 3 questions to begin with. Perhaps pick the first and last depending on how confident you are, and then have a look at the second question. When you've done that, unpause the video and we will go over it. Okay, welcome back. So we're first of all going to go through the warm-up questions. So for question A, the top is the difference of 2 squares. So I factorised it into x plus 3x minus 3, and then I factorised the denominator as well. That means that we share a common factor of x plus 3 top and bottom, which I've cancelled out, which just leaves us with x minus 3 over x plus 6. For part B, the factorisation is slightly more tricky, but there's a good clue really. If you can do one of them, so if you do the top one, then likelihood is we're going to get something that cancels top and bottom. So if you can work out there's a 2x and a 3x, you should be able to go from there. And again, these will cancel out, which just leaves you with this answer. Now for part C, I've just done that over here. This one, what's difficult about this is that the bottom is a little bit of a pain to factorise. So what I've done, I've just taken it over here, and instead of writing it as this, the question, I've factorised a negative out of the question altogether. So everybody's sign will then change, yeah? So he becomes a plus, and then a minus, and then a minus. That is much easier to factorise, and it gives us this. So all I've got to do then is I've got to bring this negative back into one of the brackets. It doesn't matter if it's this one or this one, but I need to bring it back in. Now, when I looked at what I got for my numerator after I factorised, I noticed there was an x minus 6. So therefore, I'm going to bring this back into this bracket, not both, just into this one. So that gives us the minus x minus 3. So that factorises the denominator for us. And again, we've got these cancelling, which just leaves us with this as our final answer. Okay, back to this question here. So it says for any integers, n and m, decide whether these will be odd, even, or neither. Oh, no, odd, even, or either. So this here must be even, because when you're multiplying by 8, that means you're multiplying by 2, so it must be even. If you do an odd minus an even or an even minus an odd, you could end up with an odd or an even, so it's an either. This one can be either. If you're not sure, think, I'll take an odd number, 2, and I multiply it by 3 and I get an even. Whereas if I take, no, that wasn't right. If I took an even number, 2, and I multiply it by 3, I get an even number. Whereas I take an odd number, 5, and I multiply it by 3, I get an odd number. So again, it could be either. Now this one here, this part of it must be even. And when I subtract 5 from an even number, I must be left with an odd. Okay? So now then, on to the next part. And I think it looks like this. Now, if I was teaching this in the classroom, I'd probably bring up the Dr. Frost PowerPoint, and you're very welcome to download that, but I'll write down what I would have on there. So question 1 is we need to work through x plus 3 over 5 multiplied by 10 over x squared minus 9. Okay, let me see if I can just make this a bit, I don't know how to do that, so I'm not going to do it. Okay, I'll just take some more paper if I need to. In fact, I will take some more paper. Let me do, I think, put a page in. Right, all right. So let's go again that. We've got x plus 3 over 5 multiplied by 10 over x squared minus 9. So what we've got here on the bottom is the difference of 2 squares. So what we can do is we can factorise that to get x plus 3 over 5 multiplied by 10. This is going to be really annoying if you can hear me tapping on the screen. I'll try and be a bit less irritating. Let me try laying it flat. Okay, so what we can do now is we're looking for something that's multiplying the whole of the top and the whole of the bottom. Well, that's x plus 3. It's also 5. Goes into this goes into this once and it goes into this twice. Okay, so therefore we get on the top a 2 and on the bottom an x minus 3. Okay, now for question 2, so that's this question here, I'm just going to do it here for space. We've got x squared plus x over y divided by x squared minus x minus 2 over y squared. Okay, now the first thing that you need to do is you need to look and see what can be factorised. Well, that can and that can, so I'd like you to do that. And then also think about what we do with this divide here. So I hope you remember that we leave, we change and we flip. All right, so I'd like you to get that far, factorise, leave, change, flip, then come back to me to finish it off. And back with me, so we get x plus 1 over y divided by, this will factorise into, well, it has to be an x, and it's got to be 2 and a 1. Signs are different, larger one's negative, so we get that, okay, which is leave, change, and flip. And then we can start doing some cancelling. Doesn't matter if you don't cancel. If you don't cancel where you can, you're going to end up with something more complicated to deal with in a minute. So I am going to cancel it. So we're going to take this y with one of them. And then we're going to take that x plus 1 with that x plus 1. That's going to leave me on the top with an xy. And it's going to leave me on the bottom with an x minus 2. Okay. So that's that one done. So that takes us to exercise 1b. So when you go ahead and do this, I'm going to do some more now, but when you go and practice, you can pick and choose from 1b, but make sure you can do the hardest ones, but don't do too much repetition. Okay. So back to here now, it says to add and subtract two fractions, find a common denominator. This can be achieved by multiplying the denominators and cross-multiplying the numerators. Oh, it sounds a bit blah, doesn't it? So let's just get in with an example and see how we get on. I'm going to try and see if zooming in gives me a bit more space. Is it clear that I don't really know what I'm doing? Okay, here we go, question 2. So we're going to do 3 over x plus 1 minus 2 over x plus 2. Okay, so when we when we add or subtract fractions, we need a common denominator, preferably the lowest common denominator. So in this case, it's x plus 1, x plus 2. So 3 over x plus 1, if we've multiplied the bottom, oh no, hang on, I can go back there. If we've multiplied, it doesn't like that, the bottom by x plus 2, we have to multiply the top by x plus 2. Okay, so that's going to give me, instead of just 3 over x plus 1, it'll be 3 lots of x plus 2. That funny number there is a 3. Minus, so same on the other side, multiply by x plus 1 on the bottom, so multiply by x plus 1 on the top. And that gives me, let's expand the top out, so 3x plus 6 minus 2x minus 2, be careful there, over, not going to expand the bottom because why would I? It just makes it more complex, which gives me, oh look, I've nearly got enough room. 3x minus 2x is 1x plus 4 over x plus 1, x plus 2. I think next time I'll just get a page because that does seem to be a little bit squidged. All right, so that's that question there. Let's get rid of that. Okay. If you were a little bit unsure about these, making equivalent fractions, then what I'd do is I'd take it off to the side of the page. So if you were taking 3 over x plus 1, you're going to make it into, that's rubbish, isn't it? Let's try it again. If you're 3 over x plus 1, when your common denominator becomes x plus 1, x plus 2, you're going to have to multiply the top by x plus 2 as well, and so on. All right, let's just get rid of that little lot. So that takes you to there. Good job. So now we are... oh, do you know, I just realised that's not very good, is it? I put all this question in the wrong place because that was the answer to the last one. Oh, look at that. How clever is that? Let's put that one down there. It doesn't help you lot very much if you've written it in the wrong place, but you probably didn't. Okay, so that's adding and subtracting two fractions. Right, let's see where we are next then. So on to the next page, which is this one here. And this is an exam question. It says, express this as a single fraction in its simplest form. Okay, I'm just looking at my other booklet where I seem to have another question. Have I missed one out, folks? Often we should see if there are common factors. Right, I think I've chopped a question out. So I'm going to pop it back in. So it's actually an example that comes down here. All right, so let's do that one. If you don't want to write it down, well, no one's going to be checking. But you might want to add it in. So it says we should. It's all about making sure you cancel first if you can. So it's 3 over x plus 1 minus 4x over x squared minus 1. Now, the thing here is, again, look for what you can factorise. And we can factorise, I don't know if that's going to be any better, less tappy. We can factorise this here, okay? This is the difference of two squares. So 3 over x plus 1, I think I'm responsible for the tappiness, minus 4x over x plus 1, x minus 1. I don't like that pen. Let's go back to that one. It's going to be too thick now. Okay, so what we're doing now is we're looking for a common denominator. So we're looking for the smallest thing that they go into. And the smallest thing they go into will be, I'll do them separately to start with, x plus 1, x minus 1, multiplied by blah, x plus 1, x minus 1. Okay. So this one's fine because it already is, sorry, I had to say this one. This one's fine because it already is 4x over that. This is the one I've got to deal with. So to get from here to here, we're multiplying by x minus 1. So we'll have to do the same on the top. So 3 lots of x minus 1. All right. Now, write it all now with the common denominator of x plus 1, x minus 1. The top is 3x minus 3 minus 4x, and therefore we get minus x minus 3 over, just might as well put it back as x squared minus 1, okay? Or, even nicer, take a minus on the outside, and we'll have it like that, okay? So that's your little extra example. Okay, on to the exam question we were going to look at. So that's this one here. So I think it would be a good idea if you pause the video and you did it yourself, okay, and then come back and watch me go through it. So 3x plus 5, oh, I'm back now. Well, I never went anywhere, but you're back now. So I'm going to do this question first of all, okay, and just give myself some space because you do know how I like to go on. So this is question 1. And what we are doing is 3x plus 5. I'll make this bigger. I don't know why I'm writing so small. 3x plus 5 over x plus 4, x minus 3, minus 2 over x minus 3. Okay, so this is a bit like the last question we did. It's important that we look for the lowest common multiple to be our denominator. So I was going to be a common denominator of x plus 4, x minus 3. Okay, so the top, well, to get from here to here, we multiplied by, what was it? We multiplied by 1. So the top is just 3x plus 5. To get from here to here, we multiplied by x plus 4. So we'll have to do the same on the top. Okay, so it's minus 2 lots of x plus 4. That gives me 3x plus 5 minus 2x minus 8. And then I just tend to write it like that over d, because I will write it properly at the end, but I don't like to waste time. So now we're going to put together our x terms. So they become x, 3x minus 2x. And then I'm going to put together my number terms. And my number terms gives me minus 3. And that's over x plus 4, x minus 3. So that's that one. Oh, now I've just noticed that's not that one, is it? Because I can factorise at the end. So this whole top cancels with that. So that just leaves you with 1 there. So 1 over x plus 4 is your final answer. Okay. Good. Now then, the second question. So let's just copy that one around. And I'm going to call this one question 2. And I didn't do that very well, I don't think. Let's have a look. So take that. I can do something clever with this. I don't know what I can do with this. Copy it. Copy. Take screenshot. There we go. I can do it. So I want to copy. Right. We'll get there eventually. I'm going to be a whiz at this by the time we're all back at school. Number 2. So we're going to paste that there, I think. Yep, we are going to paste that there. All right. And then why don't you pause the video and have a go and come back and I'll go through it. Good. So I'm going to begin by factorising this denominator here. And this factorises into 3x plus 1, x plus 1. Okay. And now I'm going to work out that my common denominator is going to be, for these two things, is going to be 3x plus 1, x plus 1. So it gives me 10x plus 4 at the top, minus 3 lots of 3x plus 1 there. So we have 10x plus 4 minus 9x minus 3, which is x plus 1 over 3x plus 1, x plus 1. Cancel, cancel. Obviously that leaves you with 1 there. 1 over 3x plus 1, which is the final answer. Okay, so you've now got to work through exercise 1b and 1c. So similar for 1c, if there's lots of repetition, then you can skip a couple of bits, all right? Make sure you can do some from the start, some from the middle, some from the end. And this should, remember, each lesson should be an hour long and an hour's homework. So you can always get started on the next one if you finish that one a bit early. Okay, so good luck. Have a nice rest of the day. See you later.